Hi, my name is Alvaro. I'm a student here at WGU University. I'm studying the Masters of Aeronautical Engineering here. Now, the title of my project is the Numerical Modelling for a roll-to-roll process depositing thin film semiconductor materials. Now, the area of the project is essentially the manufacturing of solar cells. Now, solar energy is clearly the way forward as a new source of energy. It clearly outweighs any other source of energy from tidal, wind, or even coal, producing up to 23,000 terawatts a year, and that clearly marks the way forward for producing energy on the planet. So in the next section I will show you a bit more about how solar energy we can study it here at WGU. So here we are in the renewable laboratory at WGU University, and this is a first generation solar panel. Its solar cells are made with a silicon wafer, and the problem with this is it's very costly to make and it's also thick. So my project looks at a way that is more cost effective to manufacture, and it also gets rid of that thickness, so it makes it more versatile. So by using a roll-to-roll process on a thin substrate, it means you can deposit solar cell material onto glass, tin, or any thin film material, making it more versatile and a greater appeal for the mass market. So WGU University, along with the Center for Solar Energy Research, patented a novel coating head for an inline process of manufacturing these solar materials. Now, this coating head works in a similar way as a printer coating head works. The printer coating head prints ink on a paper substrate, whereas this coating head prints solar materials on a glass substrate. So what my research looks at is turning this flat coating head into a curved coating head that can be used in a roll-to-roll process. And here in the O100 labs at WGU University, I'm using multiple computers, up to 10 or 15, to conduct parallel simulations with ANSYS 15 with the fluid software. So I can do multiple simulations at the same time, therefore optimizing the design process. Now, my project has the potential to impact energy generation worldwide by changing the manufacturing process and making it more industry friendly and more cost effective. Buildings like this one, the library building at WGU University, can greatly benefit from it because it can incorporate in a more cost effective way solar technology. By using these thin film technology, it can greatly reduce its carbon footprint. And not only buildings like this, but even in the motor industry and in the aeronautical industry, this film technology can have great applications within those fields. So even though I'm doing aeronautical engineering, this master's program has allowed me the flexibility to also delve into renewable energies and other areas of engineering, which is great because as an engineer it makes you more flexible and versatile in the industry. I finished my bachelor's of aeronautical and mechanical engineering at WGU, and then I got sponsored by the Royal Aeronautical Society and the Royal Academy of Engineering to come and do my master's program here. And if I hadn't done that, I wouldn't have secured the job I have, which is at Rolls-Royce in Derby.